Hello, and thank you all for joining. Today we're going to be discussing shifting security left and accelerating application deployments. The reason that we're having this conversation is because we're in the midst of a transition where organizations and companies are moving away or migrating their modern and traditional applications to more modern cloud-native deployments. And what that impact has on our traditional security role is that when we think about the security persona, they were traditionally the enforcer. This is where they could set security guidance and standards. But as we move to more modern applications, because it's focused in on the developer's velocity to be able to address customer pain points and problems, the security team is actually pulled from that development pipeline and is now the enabler. Security could set standards, but they lose the ability to actually enforce governance or secure practices. So what we need to start considering is how do we bridge the gap between development and security to ensure that as we are introducing this migration, we are not introducing more risk to our organization. And most organizations today are on this path to modernize, because organizations can deliver revenue generating features faster and be more responsive to their customers. They can reduce technical debt as well as take advantage of cloud efficiencies. However, development and security teams must modernize the way that they think about and practice security, governance, and compliance to instill confidence in faster release cycles. With over 149,000 CVEs identified in 2020 alone, the security risk is only growing, and if application hygiene is left unchecked, your exposure is steep. So how do we get development and security on the same page to enable fast deployments with reduced risk? It's time to shift security left and adopt a DevSecOps approach to modern applications. DevSecOps means that security becomes an integrated part of the container lifecycle, enhancing the security posture while streamlining a faster path to production. It's when security requirements are introduced early in the lifecycle so that we prevent redoing work later on, which slows down the DevOps pipeline and could increase overall costs. And VMware understands the challenges that development and security teams are facing when delivering modern applications at scale. We have a comprehensive solution set and designed to help secure and accelerate the entire container lifecycle from code to customer. So let's see how we can achieve this with VMware. We will start first with an overview of Carbon Black container security offering, and then later we will transition to view it from the developer's perspective of how Tanzu delivers additional security value to the customer. Carbon Black Cloud Container Security is designed to identify and mitigate risk to containers through the enforcement of industry configuration standards. Now, why is this important, right? Gartner actually claims that misconfigurations pose a higher level of risk to organizations than even a workload compromise. So what we're going to provide access to for you across your entire enterprise is risk prioritization based on Kubernetes configuration standards. So you'll be able to assess across your enterprise where we have things allowed, such as privilege escalation, what workloads are associated with that particular configuration. And this is key because Kubernetes was designed to be easy to get it up and running. Defaults allow things like privilege escalation, which could lead to a container escape. Or let's take, for example, networking. Networking actually starts with an allow all communication rule, which could lead to a denial of service threat if not corrected. What is foremost important is understanding your assumed risk across your enterprise assets. Now we take these different configuration standards and we prioritize that risk based on 3 different factors. We're looking at confidentiality, integrity, and availability. Now, confidentiality takes into account exposure of PII or access to secrets. Integrity will calculate in if the host or cluster can access and change runtime behavior or launch new pods. And availability starts to take into account exhaustion of resources or denial of service threats. So on each risk that is identified on these workloads, you'll be able to depict all of those different items, as well as a key factor of exploitability, right? How easy is this configuration to exploit? Now, to articulate the risk of these different default configurations, Kubernetes actually defined what is called pod security standards. And pod security standards go in and identify what those key risks are and essentially recommend best practices from a security standpoint to reduce risk. Now, the two key policies is our basic or baseline policies as well as restricted. Baseline is intended to block privilege escalation, but be very easy in terms of adoption, whereas restricted is more from a hardening standpoint where we can start to assess what our critical assets are and where we need to harden and lock them down further. Now, taking recommendations from Kubernetes is going to be key because this is typically a best practice for security administrators to enforce on their modern applications, because security is accountable for the security of the modern applications, and it is a best practice to do so. Now, we need to make sure that this is easy to implement. So through the console, we have streamlined the ability to actually apply templated configurations. So if you wanted to enforce across your assets the basic Kubernetes standards in terms of those configuration settings, we can select these different templated policies. We also offer continuous compliance by being able to apply CIS benchmarks, which aligns to their 5.2 section of pod security policies. All of these configurations can be changed from alert to block. The intention here is to make sure that we are not impacting any of your operations. We want to be able to assess what this is going to look like right at the onset. Oftentimes for security teams, this is new, and so they are looking for security guidance or recommendations for what to apply. That's why we have these templated policies. But what typically is a challenge for teams is if they were applying this on their own, there are many different steps that are involved to getting this to be accessible for your global enterprise. But the challenge becomes, how do we ensure that we're not impacting velocity or business operations? So within the same workflow, we are actually identifying these key configurations and violations that are associated if we were to start enforcing it. Through this screen, you're actually able to build in exclusions as you see fit to ensure that your operations are continued and we are not introducing any sort of developer friction. Now, marrying this functionality with the ability to identify and restrict images with critical vulnerabilities is key in the success of securing your modern applications. As mentioned in the slides, more than 149,000 CVEs were identified in 2020 alone. If you were, for example, to scan Docker's official images with the tag of latest, more than 90% of those images contain a high or critical vulnerability. Now let us take a step back in our policies and assess the rules associated with image vulnerabilities. From an image vulnerability standpoint, we are able to enforce this both in the build and deploy phases of the development lifecycle. As we shift further left into the build phases, we need to ensure business operations are maintained and that we do not impact velocity. You can see here that these two icons actually indicate what we can enforce in that build phase. So if vulnerabilities have an available fix, or there's a critical vulnerability identified, I want to restrict this from progressing within my CI pipeline. For this reason, as well as security and compliance, we have built a CBCTL feature which actually integrates into your existing CI tools to be able to inform the DevSecOps personas of the required fixes to allow progression into the development pipeline. This is us starting to marry the security and development teams together so that we can progress this in more of a timely fashion. What you will see in the next portion of the demonstration is the build pipeline experience through Tanzu protected by Carbon Black container security. What you will see is us go through that experience by leveraging different images that we're attempting to push into production, two of which actually have associated vulnerabilities. As you can see in the console here, these two images that we will be looking at have critical vulnerabilities that have an associated fix available. Note that neither of these images have an associated running workload because we are preventing it from being deployed into production. Whereas when that is actually fixed on that image, we no longer have those critical vulnerabilities, nor do we have fixes available. We're able to allow this to successfully deploy into that pipeline, providing the security team the insight into what are those vulnerabilities, what are those fixes, building in exclusions, and what are the packages associated with this particular image build, making sure we're looking at solving this problem holistically and in a unified manner. So this concludes our quick overview of Carbon Black container security. The intention is to deliver functionality that is key to developer and security personas, bringing it together so that we can empower the DevSecOps role to adhere to security guidance and best practices and assess and understand what vulnerabilities exist within your existing workflow. Let's go ahead and pivot over to Tanzu for a demonstration by Tony, where he will take us through the developer's workflow, focusing in on the build pipeline and talking about some of the additional security features that Tanzu deploys.
All right, thank you, Sanara, and thank you everyone for watching. So what you just saw was Sanara setting up policies on Tanzu Kubernetes Grid to help secure the platform itself. What I'm going to walk you through is this DevSecOps flow to get code from the developer in front of the customer. I'm going to do this using a few products from the Tanzu portfolio. I'm going to start with an application written in Spring Runtime. Now, with all of these development frameworks that are out there, whether that's Spring Runtime or Steel Toe for .NET, they're really bringing a lot to the table. With these cloud-native application architectures, developers really have to know a lot about how to build more than just their application. There's service discovery, observability, secrets management, and a whole host of other things that developers need to be aware of. And understandably, developers are not going to be experts in all of these particular areas. So what we find is developers going to open source to find these functions and capabilities, and it could be leaving your applications vulnerable if that is not from a trusted source. Spring Runtime and similarly Steel Toe provide a trusted source for these sorts of capabilities. Developers simply need to click off the capabilities that they need, and a starter application will be built for them that they can download and start building their code and features that their customers actually want. Next, I'm going to build that code using an application called Tanzu Build Service. Now, Tanzu Build Service represents a better way to build containers. Tanzu Build Service does not replace your continuous integration pipeline. It simply replaces the part of the pipeline in which you build your containers. So think Docker build, Docker tag, and Docker push. What I will show is how to build your initial application using a declarative image manifest that Tanzu Build Service will manage and keep up to date. It does this by monitoring 3 functional layers of an image. First is the source code, which we already talked about. Second are the build dependencies. So in this case, for Java, these would be the Java build dependencies. And third are the base OS level packages. Tanzu Build Service monitors each of these 3 layers for changes and builds new containers whenever one of those 3 layers changes. Next, Tanzu Application Catalog represents a better place to get open source applications. Whether that be for embedding in an application via a Docker file, such as base OS images or build dependencies, or whether that be for backing services like MySQL, Redis, or Postgres. Tanzu Application Catalog monitors these upstream projects and builds new containers based on those upstream projects daily and pushes those to your private repository. All testing of these applications is taken care of, including regression testing, vulnerability scanning, and detailing every package that's within that container. And all of that is made available for your developers. Next, I'll be pushing these images to Harbor. Now, Harbor represents our image registry within the Tanzu portfolio. Harbor is nice because it includes several other services besides a simple container registry, such as a Helm chart registry, image scanning, and a notary image signing server. I won't be going too deep into Harbor, but you should get a view for how it looks. And finally, I'll be pushing all of these to Kubernetes, where the policies that Sanara set up earlier are deployed. Now, all of these products taken together have capabilities and integrations that provide more functionality than simply the sum of its parts. But that said, this is not an all or nothing conversation. You can run this entire demo using Spring, or .NET, or even Python, or Node, or any other reasonably popular language. You can also build Spring without Tanzu build service. You can build it with Docker files or any other method you use to build containers. And you don't have to use Harbor for an image registry. You can use Artifactory or any other OCI-compliant container registry. It's up to you. With our Tanzu catalog, the batteries are included, but swappable. Okay, let's get on with the demo. So like I said, I'm going to be starting this flow of our DevSecOps demo with the source code. This is source code written in Java and the Spring framework, and it's an application called Spring Clinic that we use for these sorts of presentations. And once my application is built using Tanzu build service, I'll push it to Harbor. And to my Harbor project, and into my Spring Clinic registry. And as you can see, as right now, the registry is empty. Okay, now let's go look at Tanzu build service and how to build our first application. Okay, so the first thing I need to do is tell Tanzu build service what application to build and how I want it built. I can do that simply with this command, kp image create. Here, I am giving Tanzu build service the name of the application I want it to build, where I want that image to be pushed via the tag flag, the Git repository where my source code lives. This represents that first functional layer of a container image, the source code, which Tanzu build service will monitor for changes. And here you see I'm monitoring Git revision main. Now, this is the main branch of my project, and normally in production you would not monitor the main branch because this would go around any CI pipelines, regression testing, or other testing, which you're probably doing as part of your deployment pipeline. I'm doing it here for simplicity, but there are many other ways to monitor your source code. Here I'm telling Tanzu build service to use cluster builder base. Now, this is the other two functional layers of the container image which Tanzu build service will monitor. The cluster builder represents the set of cloud-native build packs as well as the stack or base OS level images which Tanzu build service will use to build my container. And this wait flag just tells Tanzu build service that I want the build logs streamed to my local console. Now, this will work fine, but in a CI pipeline, you may not want KP in your tool set within your pipeline. So instead, we've included a couple other flags which you can use to create Kubernetes native image manifest. Here, I'm providing the dry run and output flags, which will tell Tanzu build service to create me a manifest, which I can apply to Kubernetes directly. Here's a standard image manifest that I can apply to Kubernetes and customize to get even more granular control over my image manifest. I can also save that into a file to be later used in a pipeline or stored alongside my code in my repository. Okay, let's go back to our standard kp image create command and execute. Now, notice these stages that Tanzu build service is going through. First, we set up the certs so that it can access my Harbor registry. Then it's going to prepare the image for building. And it's going to say a reason why we're building that image. Here we see that it's because the source code has changed, because this is a brand new image. Next is going to go into the detect phase, and Tanzu build service is going to scan our application code and determine which build packs it needs to build our application correctly. Then it's going to analyze the image and see if there's any other cached images that it can pull layers from. By default, when a single functional layer of a container image changes, Tanzu build service won't rebuild the entire container. It will use cache layers for the pieces that haven't changed, and you'll see that later on in the restore phase. Next, we move on to build. And here we see your standard Maven downloading of dependencies. I'll speed this up so you don't have to watch Java compile. Okay, there we go. Our container image has successfully been built. Here are the last couple phases within Tanzu build service, this export phase, where we're adding in the functional layers to the container image and integrating that container together. And finally, the completion phase, where in this case, we just have a build successful message. Okay, let's flip over to Harbor and take a look at our container. And here we'll refresh. And there's our container. Okay, I'm going to grab this image tag so I make sure I'm deploying the correct image. Okay, now let's go back to our Kubernetes cluster and deploy this. Now again, much like monitoring the main branch with Tanzu build service, I am not going to be using a standard continuous delivery pipeline in order to publish my application into production. Here, I'm going to be using just a standard Kubernetes deployment YAML template. And here, I'm going to change this from latest. I'm going to put in the tag of the container image which I want to deploy. Okay, now let's go ahead and get this deployed. Uh-oh, it looks like my deployment was denied by a Kubernetes security policy. I wonder if there might be any known vulnerabilities in my container image. Now, unbeknownst to you, I actually did build this image with a very old version of Ubuntu as my base OS image. I did this because I knew it had severe vulnerabilities and it would get rejected by Kubernetes, and I wanted to show this functionality. But should I want to scan my image for these vulnerabilities and get a report? Like I said, Harbor includes container image scanning by default, but so does Carbon Black. Let's take a look at that here. Now, CBCTL is Carbon Black's CLI tool, and here I'm giving it the image scan command, along with the URL to my container image and its tag. Let's go ahead and run this, and I'll speed this up. Okay, there we go. Here's our scan report. Now let's take a look. Yep, here's our issue. Remember earlier, Sonara set policies on our Kubernetes cluster to disallow any containers with vulnerabilities that had fixes available. Here we see we have several. Okay, let's go back and update our container. Okay, so now I'm putting my operator hat on, and I know that I'm building containers using an out-of-date base OS image, and I need to get that updated. So the first thing I'm going to do is head over to the Tanzu network. The Tanzu network is your source for all Tanzu products. In this case, what I need to find is the base OS image for Tanzu build service. If you recall, I built this image manifest using the cluster builder called base. So let's search for that. Okay, there's my base stack for Ubuntu. In here, I see a list of releases. Let's get the most current one. We'll go into the artifact references, and here I see a build and a run image. Tanzu build service uses two images to build and run your containers. One includes all of the build dependencies, and the other includes the dependencies simply to run your application. This way you're not running potentially vulnerable build dependencies in production, which are not necessary. So if I click on this I button, here I get the address of where that image resides. Let me go back to our cluster. Now to update this, I just need to run this simple command. Now recall 1.1.3 is the most current image that I can deploy. Here, I'm using KP and passing it the cluster stack update command with the name of the base image that I wanted to update. And I'm giving it the URL for the build image and the run image. As an operator, this is all I need to do. Running this will start downloading the latest images and push those to Tanzu build service. And once again, I'll speed this up. Okay, now our cluster stack is updated. Let's take a look at our builds. I can use the KP command here to show a list of our builds. And if I throw watch in there, oops, we can see that command run every 2 seconds. Now here, we see the Tanzu build service has picked up on the change to that functional layer, the stack, over here in Reason, and is currently building our new image. There we go, all done. Wow, that was a lot faster. Let's take a look at the logs and see why. Here we'll take a look at build number 2. That's interesting. There's a lot less logs in this build. And that's because, again, we're not recompiling and rebuilding the entire container. We're only rebuilding the parts of the container that needed to be updated. In this case, the stack. And here you can see the reason for this. And here you can see in this phase, the rebase phase, where most of this work is happening. We're simply leaving the rest of the image as it is and slotting in a new build and run image. Okay, let's flip back over to Harbor and take a look. And there's our new container. Now again, I'm going to take this tag and copy it and back over to our CLI. And again, let's scan this just to make sure before we deploy it. Again, I'll speed this up. Okay, now here's our vulnerability report. Let's take a look. So no more high severity vulnerabilities, and none of them have fixes available. Okay, let's deploy this again and see if it falls within our Carbon Black policies for Kubernetes. Let's go back into our deployment YAML and fix that tag. There. Now we'll be deploying the image which has been patched. And let's go ahead and give that a try. Oh, looks like it went successfully. Let's watch. All right, it looks like our image is deployed and running. Let's go ahead and expose it so we can take a look locally. And we'll wait here for our external IP. Okay, there we go. Let's grab that. And there's our application up and running. Okay, that's enough for me. Thanks for watching this demo and enjoy the rest of your conference.
Now let's bring all of this together with how you can deliver better outcomes for your business. We can look at this through the lens of the DevSecOps. The first outcome is developer velocity. Developers spend more time coding, they can be more productive and release more frequently. The second outcome is improved security posture. With visibility, code, automation, and policy control, teams can remediate vulnerabilities faster, automate policy compliance through the CI/CD pipeline, and reduce that toll in managing security for your organization. By shifting security left and providing full vulnerability visibility, we can start to build a security culture based on trust and awareness. And the third outcome is operational efficiency. Make it simple for operators to manage hundreds of Kubernetes clusters across teams, clouds, and used from a global control plane. You will be able to meet service level objectives, indicators, as well as reduce time for repair for issues that do occur. And with that, we thank you for attending our session today. Please visit our website for more information on either of our offerings, and I hope you enjoy the rest of the conference.